Hello everyone, welcome to Tecto.com. In this question, we have to find out for a given schedule. This one is a schedule. So, for a given schedule, under which timestamp protocol it is allowed. So, we have two kind of timestamp protocol. One is basic, and another one was bit enhancement over basic timestamp protocol, which was called Thomas Wright rule. Okay. So, first what I have done is this is the same schedule I have written in tabular format to understand it properly. It will be like easy to understand. And first, basically, we need to understand what is the rule or what are the rules over which we will decide whether this is allowed under particular uh, timestamp protocol or not. Okay, so fine. So we may have two conflicting operations in case when a transaction Ti wants to perform read operation on a variable x, and the second case can arise when transaction Ti wants to perform a write operation over the variable x, right? So basically we have three kind of conflicting operations, that is write read write and write read. So except read read, other three combinations are conflicting operations. So for a variable x in timestamp protocol, always there are two timestamp are maintained. So first one is read timestamp, okay, another one is write timestamp. Okay, so what is this read timestamp? This is the timestamp value of the transaction which has performed last read over x. Okay, so for this variable x, in read timestamp we store the timestamp value of that transaction, that is the timestamp value when that transaction has started. Okay, now in write timestamp, we store the value or the timestamp value of the transaction which has performed last write over x. Okay, so these two values are stored for each variable. Now, see this first case when Ti wants to perform a read operation over x. So what we need to check? We need to check whether the timestamp, read timestamp or write timestamp value of x is greater than or less than the timestamp value of Ti. So in first case, we will check whether the timestamp value of transaction I is less than write timestamp value of x. What does it mean? If it is true, it means that after arriving this transaction Ti, another transaction has modified the value of x. Okay, so the timestamp values for a variable is modified only if something else or read or write has been performed by some other transaction, right? So it means that some other transaction who arrived later has overwritten the value of x. Okay, so this will be discarded. Okay, so this operation will be discarded and the transaction will roll back. Fine. And except this case, everything else is allowed. Okay, so otherwise allowed. Okay, so we need to check only this condition. Fine. So if this is true, we discard the transaction and roll back, otherwise we allow. Fine. Now the second thing is this transaction Ti wants to perform a write operation over variable x. Okay, now so write may have conflict with read or it may have conflict with write itself. So here first thing we check is whether timestamp value of this Ti is less than read timestamp of x. So if this is true, it means, what does it mean? It means that a later transaction which has arrived later than transaction Ti has read the value of x, right? So if this is true, it means a later transaction has read the value of x, and if we proceed the transaction Ti, it may not be recoverable and there will be a case of inconsistency, right? So it's like uh, a transaction Ti arrived at some point and T2 has arrived. Now Ti arrived at, let's say, 10 and it is arrived at 11. Now 11 has already read the value of x, and then this transaction Ti wants to modify, then transaction T2 will have a value which is modified by Ti, I mean transaction 1, right? So this is a case of inconsistency. Fine. So this Ti will be discarded and roll back. Okay, so discarded and roll back. Fine. Now we may have other condition that timestamp value of Ti is less than write timestamp value of x. What does it mean? It means that a later transaction which has arrived later than transaction Ti has overwritten the value of x. Okay, so the value of x which is going to written by transaction Ti here has already been written by some other transaction. Okay, that's why the timestamp value was modified. Now what I'm going to do is this transaction will override the value. Okay, so this is not considered to be correct in basic timestamp protocol and discarded, and the transaction is rolled back. Fine. Now this is the overall modification. So this was which we have studied is basic timestamp protocol, but in case of Thomas Wright rule this last condition is allowed. Okay, so in case of basic timestamp protocol we are discarding in this case, but in case of Thomas Wright rule we will accept, I mean we will not discard this, we will simply ignore this right. Okay, what we do in Thomas Wright rule, we just ignore this. Fine. So now we have to find out what is the case, I mean what is true in case of the given schedule. Fine. So we have read here, so this has no conflict with the earlier operation. This is the first operation. Okay, and it has been given that Ti started execution first. Okay, so of course the timestamp value of Ti, timestamp value of T1 will be less than timestamp value of T2. Okay, fine. Now this is read y, so this is variable y, another variable, so there is no issue. Now this is performing write x. Okay, so write x, as it is write x and this is time so what will be the value of read x, the read timestamp of x when this is performing write? So this is read timestamp value of x will be less than Ti, right? So this, it will be exactly opposite of this. Okay, so there is no case of rollback for this. Now we have write x. Fine. So write x is, it will have conflict with this, right? Here there is conflict. So what do we need to do? Now we need to check, I mean what we are trying to do basically. We are this transaction Ti, that is T1, wants to perform a write. Fine. Now what is the timestamp value for that moment? What is the write timestamp value? So for x, write timestamp value for x will be equal to T2. Fine, right? Timestamp value of transaction 2. Why? Because this is the last write it has, T2 has performed over x. Okay, now when I am comparing, we will have to see whether, now Ti wants to write, so we will see whether timestamp value of Ti, that is timestamp value of T1, okay, is less than write timestamp value of x. So this is true, right? Because write timestamp value has just been modified by transaction 2 and T2 arrived later. Okay, so this will be true. Fine, so this will be true, this condition will be true. So basically second condition is being true. Now in basic timestamp protocol what do? We discard and roll back, right? So in case of basic, this schedule will be here, this transaction T1 will be discarded and rolled back, but in case of Thomas Wright rule, we accept this, okay, and just ignore this right, okay. So simply we know now that this schedule will be allowed under basic timestamp protocol, but will not be allowed. I mean, will not be allowed under basic timestamp protocol, but will be allowed under Thomas Wright rule. So which one is the option which is saying this? So it is allowed under basic timestamp protocol. This is wrong. It is not allowed under basic timestamp protocol. Okay, stamp order protocol, but allowed under Thomas Wright rule. So this is right. Okay. So B is our correct option.